Dear students, in this session we will learn about molecular velocities. In the sample with the gas molecules, these gas molecules are in a constant motion. They move to and fro, they move in different direction and their velocities are continuously changing both in magnitude and direction. So if I say molecular velocity, sometimes it may be inappropriate. The most suitable term is molecular speeds because velocity is a vector quantity, speed is not. So I should say RMS speed, average speed, most probable speed rather than calling as velocity. But because most of the books keep writing velocity, I also kept the same. RMS velocity, average velocity, most probable velocity. These are the different types of molecular velocities. We will see one by one. Now what is root mean square velocity? This is nothing but square root of the average of the squares of the molecular speeds in a gas molecule. Now you see Vrms is equal to square root of Vn square plus V2 square V3 square up to N square divided by N, where N is the total number of molecules, V1, V2, V3 are the velocities of individual molecule. You sum up the squares of this, take average, then you take root of this, square root of this, it will become Vrms. Now these are the mathematical expression for RMS velocities for 1 mole and for 1 molecule. The derivation is not included in the syllabus, so I am not discussing it. Root mean square velocity for 1 mole is given by square root of 3RT by m. Here R is the universal gas constant, T is absolute temperature, m is molar mass. So for 1 molecule, you have to consider Boltzmann constant, which is nothing but R by N, where N is Avogadro number. Okay, so when you make R divided by N, that is Avogadro number, that becomes equal to 1.38 into 10 raised to minus 23, because Avogadro number is 6.022 into 10 raised to 23, that goes up, it becomes 10 raised to minus 23, and this is 8 by 6, it becomes 1.38 close to, and T is absolute temperature and m is mass of the single molecule. Now coming to average velocity, this is very simple. It is average of the speed of individual molecules. So V1, V2, V3 are the speeds of individual molecules, and is the total number of molecules. You take the average, and that is nothing but average speed or average velocity. These are the mathematical expression. For 1 mole, average velocity is a root of 8RT by 5m. Again, R is universal constant, T is absolute temperature. You know the value of phi, that is 22 by 7. For 1 molecule, that becomes root of 8 kBt by 5m. Instead of R, you have to write kb, that is Boltzmann constant. Now most probable velocity, as the term indicates, it is the most probable speed. Okay, the speed possessed by largest number of molecules in a gas sample at the given temperature. Mathematical expression is Vmp is equal to root of 2RT by m. Again, these are constants, m is molecular weight, and for a single molecule, R is replaced by Kb. Molecular weight is replaced by mass of single molecule. Okay. Now, this is in summary. We will find the ratio of these. We can find the ratio of average to most probable by dividing the expression, mathematical expression, it becomes 1.13. RMS to most probable, it becomes 1.22. RMS to average, it becomes 1.085. You simply have to divide this expression. Now, if you take the overall ratio, that is RMS to average to most probable, it becomes 1.22, 1.131. That means RMS is the largest, then average, then most probable. So these are references for this. Thank you. Thank you for watching.